Hello everyone and welcome back to the channel. Today, we're diving into the absolute fundamentals of electrical circuits. These are the rules that govern everything from your phone charger to the power grid. So, let's get started with the big one, Ohm's law. It's a simple but powerful formula. Voltage equals current times resistance, or V equals I asterisk R. Think of voltage as the pressure pushing electricity, current as the flow of that electricity, and resistance as what's trying to slow it down. If you know any two of these, you can always find a third. For example, if you have a 12-volt source and a 4-ohm resistor, you can calculate the current by rearranging the formula A equals V. So, 12 divided by 4 gives you 3 amps of current. Super useful, right? Next up, we have Kirchoff's laws, and there are two of them. First is Kirchoff's current law, or KCL. This law is all about junctions, or nodes. Where wires meet, it states that the total current flowing into a junction must equal the total current flowing out of it. Imagine water pipes meeting at a T-junction. The water coming in has to go out somewhere. It can't just disappear. So if 5 amps flow into a node, and one path out has 2 amps, the other path must have 3 amps. It's the conservation of charge in action. Then we have Kirchhoff voltage law, or KVL. This one applies to any closed loop in a circuit. It says that if you travel around in a complete loop, the sum of all the voltage drops across the components must equal the total voltage supplied. In other words, all the energy supplied by the source gets used up by the components in the loop. The voltage gains equal the voltage drops. This is perfect for analyzing more complex circuits with multiple components in series. Finally, let's talk about something that's often overlooked: the internal resistance of a power supply. In an ideal world, a 9-volt battery would always provide exactly 9 volts. But in reality, every power source, whether it's a battery or a lab supply, has a small amount of internal resistance. Why does this matter? Well, when you draw current from the supply, a small amount of voltage is lost or dropped across this internal resistance before it even leaves the battery. This means the actual voltage you get at the terminals is slightly less than the advertised voltage, especially under a heavy load. It explains why your car's headlights might dim for a second when you start the engine. The starter motor draws a huge current, causing a significant voltage drop inside the battery. So, a quick recap: Ohm's law helps us relate voltage, current, and resistance. KCL tells us that current is conserved at junctions, and KVL tells us that voltage is conserved in loops. And internal resistance is the real-world factor that makes our power supplies a little less than perfect. Mastering these concepts is the key to understanding almost any DC circuit you'll encounter. I hope this breakdown was helpful. If you enjoyed this video and want to see more, please hit that like button and subscribe. Let me know in the comments what topics you'd like me to cover next. Thanks for watching, and I'll see you in the next one.